Completing our schedule this evening is Pedro Barbosa, Fotec Solutions Industry Sector Manager for Pipelines. He has almost 15 years experience in the pipeline industry, initially working as an integrity engineer for European National Gas TSO, and then as a project manager and business development manager for an inline inspection service provider before joining Fotec Solutions. Fotec Solutions is a launchpad company from BP, leading the development of distributed acoustic sensing solutions for pipeline monitoring applications for over 12 years. Pedro's presentation will highlight the benefits of an integrated pipeline monitoring solution using distributed acoustic sensing and unmanned aerial vehicles, or UAVs, or drones, for a rapid detection and response against third-party interferences and illegal hot tapping activities. So welcome, Pedro.
Thank you, Danny. Hope you can hear me well. I appreciate the opportunity to present. We discussed today, I've seen a few presentations about fiber optic sensing and specifically DAS, and how they can actually be very useful to detect third-party interference. I'll try to go a little bit further. It was mentioned earlier that not just detecting, but characterizing and also responding fast, it's very important, specifically in some countries. So I hope that this presentation will be interesting in that perspective. So first of all, just a quick word about Fotec. Fotec was founded in 2008. We've been also leading the market in terms of distributed acoustic sensing. Just recently, last year, we were acquired by BP. So we are a launchpad company by BP. We've been monitoring in multiple sectors. Specifically today, the talk is about pipelines, but we also work in smart cities, infrastructures, and security. And we are truly a global company. So we have installations in 27 countries at the moment, so reference from this year. We have over 400 installations and at the moment over 7,000 kilometers of pipelines monitored. So some of our current clients, some of the major pipeline operators and some IOPs as well. So what is DAS? It was already discussed a few times today. We use basically fiber optic as a sensor. Our system will send pulses of light that will be received, so there will be a backscatter. And when there is an interference, any change in the signal, those changes will be monitored and it will be analyzed by the system. So we have complex algorithms based on artificial intelligence and machine learning that can actually not just detect, but then identify what is causing the disturbance. What are the core challenges that this system can tackle? Criminal activities, so illegal hot tapping, third-party interferences, leak detection, also mentioned, but also peak tracking, also mentioned today, and geohazard detection. Technology is fairly new compared with other technologies used in the industry, and it's progressing. So there is a lot of research and development. So I truly believe that these lists that you see here will increase over time with other capabilities. So it's a single system. And before I go into the topic per se, let me just show you a quick video of a demonstration. So this was performed in one of our facilities in the US, where you have on the left-hand side the map that is visualized in control room, for example, and on the right-hand side you'll have the signal or the signals coming from the fiber. So we have a graphic here of distance versus time, where you can see the disturbance that the vehicle is actually producing and the fiber that is buried is catching. And you can see that alarms are raised within seconds and they are pinpoint on the map in real time. So a system with multiple capabilities per se. So in this case, you have vehicle detection and alarming. you have a person walking, and as you can see, after 2 or 3 seconds, a walking alarm. You can see how the signal is also different. So we use a set of characteristics from the intensity of the signal, the frequency, the location, if it's moving or not, if it's persistent. So it starts digging, and again, after a few seconds, you can see digging alarm coming up, the exact location. We're talking about a couple of meters. Our resolution is less than 1 meter, but depending on the characteristics of the installation, let's say a couple of meters in terms of accuracy. So a typical system, or any system, will be composed by hardware and software. But something that is also important, if not even more important, is calibration. This is not a out-of-the-shelf type of system. This is not something that you buy and you install by yourself, like you do with a printer or any other IT that we have at home. So it will require some calibration, some tuning, precisely to avoid some of the issues that was already mentioned also earlier today, which is false positives and false alarms. So let's take a look one by one. So the hardware, it's really the foundation for detectability and for locating. As you can see in the example, you have an experienced eye can actually see that this is a car, this is a person walking, there is an angle, so it's moving, and you have not in an angle, so there is not moving, a more energetic type of signal, which is the excavation, which you can see here. So the car, the person, and the digging. So this is what the hardware, different hardwares will be able to do this. However, when you pass into real life, the software will play a very important role to differentiate different signals that are happening in the same location, classify it, and identify what is what. So, and at the top, you can see the testing. It was under control conditions, so not much noise around. And then you can see a real life example. This was a leak detection alarm from an installation in India in 2017, where you can see that no human, man or woman, will be able to detect with a naked eye what is happening there. And that's why strong algorithms are so important. So if you go a bit deeper in this example, so what the software does is it filters the noise in steps. It will analyze the characteristics of the signal. So in this case, it's continuous. It persists in time. It's not moving spatially. It has certain frequency, certain intensity, and the system will classify it as a leak. So all this process happens in real time. Alarms are raised within a few seconds or a couple of minutes, depending on how confident basically we want to be. And when you want to react, being very confident is important. But to be confident, we have to have a very reliable system. System performance is affected by multiple characteristics. It will be affected by the fiber optic itself, the position of the fiber optic, the soil type. Is it sand? Is it clay? What is the water content? So many aspects will affect the reliability and the performance, but not just the exterior effects. The system itself, I like to see it as a triangle. It's really, playing a bit with the resolution, which in our case is less than a meter, the range, again, up to 100 kilometers, and the sensitivity of the system that will allow detect the the detection of different systems with different intensities, call it like this. You may need a very sensitive system for something that is less energetic, while you don't require much sensitive for something that has more energy behind. However, if you want to increase sensitivity or resolution, for example, you will compromise range and you will compromise sensitivity. So you cannot have the best of the world in one system. You really need to tune it and to calibrate it for what is required. And this is really where Fotec, we are quite proud to have that experience. It's actually one of our key benefits. We have over 80,000 hours of software development, and we have hundreds of installations all over the world. And that really gives us that reliability that allow to have a very low false alarm and false positives. Again, this is for real installations where you have noise behind and not a test or a laboratory or in laboratory environment. Why is this so important? And a bit about the topic now to the presentation. Because if you want to react fast, you want to react to the alarms that really matter. So the way we alarm, we will have a three-stage alarm. So from green to yellow and then to red. This is set in advance, again, during calibration, and with the operator, we'll try to understand what are the main problems and what are the threats that actually require immediate response. So typically this will be illegal hot taps, third-party interference, not so much if it's a car, even though a presence of a vehicle in a non-authorized area can also be an alarm. So this has to be defined in advance for the entire pipeline. What we want to avoid is really to have a drone, so in this case, an automatic response of a drone being deployed unnecessarily. You can easily have, and I've heard today someone saying potentially thousands of events in a day. I would say easily thousands of events in a day. And you want to make sure that you don't have the drone back and forth all the time. You want it to have deployed when is necessary. So the specification of the drone is also very important. If you want to have a system that actually is fully integrated, the selection of the drone is actually critical. We don't offer the drone service, so we have partners and we have companies that work with us for that. The advice is pretty much the same. So they advise a helicopter type of drone, which is able to have a vertical takeoff and landing. That's quite important if you have a few drones deployed and they are deployed automatically. You want also to protect them when they are on standby. And also when they are hovering over a certain location, it's important to have stability. Drones nowadays also use artificial intelligence. You can actually have drones with sensors that are able to recognize faces, recognize people, and follow vehicles and persons if they try to escape. And you have actually a very powerful deterrent to criminals, for example. The speed is also very important. There are, I would say, a few considerations regarding speed, weather conditions, for example, among others. I will touch a bit about that in one of the examples, but also range and autonomy for appropriate response. So with a drone that is automatically deployed after fiber optic sensing, detecting an event, you can actually reach a remote location quite fast. So there are many advantages. So faster response time, there is less risk or even virtually no risk to lives of security teams. They can be deployed afterwards, after the situation being assessed. The ability to assess a threat before humans arrived provides deterrence as well, but also requires evidence. And in case of criminal activity, acquiring evidence is actually also quite important. Also, the ability to follow, as I've mentioned, is also something a drone can do. So what are the examples of an integrated solution? So first example I have here is an illegal hot tap. This is from installation we did in India in the past. We detected in this case 26 hot tap attempts in 6 months. If you have confident in your information, if it's reliable and you know that is there, the drone could have been deployed. So in this case, there was no drone, but by understanding really what is required for response time, you can actually even prevent some interferences to happen. So for example, in terms of distributed acoustic sensing, we can assess the depth of burial, the soil conditions, and the method of digging to try to estimate how long will it take for someone that is digging reach the pipeline. In terms of the UAV or the drone, the time to raise an alarm and launch is important, but also the velocity and the range. So all these parameters worked in advance can going from basically detection, classification, and alarming to potentially prevention with a fast response, which ultimately is what most operators are looking for when you talk about third-party interference, is to prevent the incident. So we have an example here, a very simple example, but let's suppose that we have roughly 2 meters deep, pipeline is 2 meters deep, with some clay contact, and they were basically digging with a spade and axe. We can easily estimate it may take more than 45 minutes to dig up to the pipeline. If you work out with an UAV, let's say 5 minutes until it's in the air after the DAS being able to detect, to alarm, to have a good confidence it's not a false alarm, and to UAV to be deployed at a certain velocity, let's say 90 kilometers per hour, we can estimate that it will take around 40 minutes of flying to reach up to 120, let's say 100 kilometers if you consider flying against the wind, for example. So this is just an example. It is not real, but you can easily work out how many drones you need, the type of drone you need, and if you are confident in your DAS provider and in the reliability of the system, we're also confident you are not chasing a false alarm. Another example is unplanned maintenance, so a third-party interference that is not criminal. So in this case, it is actually from South America, also an example we had. Multiple locations, so there were actually 2 mechanical diggings happening at the same time, 200 meters apart. In this case, the crew did not manage the pipeline, so this was actually a true third party, but it could have damaged the pipeline. As it was already mentioned today, mechanical damage is actually the most common cause for pipeline incidents, leakages, both in the US and in Europe. I'm not going deeply through what CONCAWI and PHMSA and EGIG and other entities are providing in terms of statistics and data. We've seen that already today, but it's clearly, if not the number one, and it is the number one, but it's for the future as well, for sure, one of the main reasons for pipeline incidents. But again, it was also mentioned today, I want to pass the message that this is just another barrier, right? If you look into risk assessment, if you look into improving pipeline protection, I don't want to pass the message that DAS is the only solution. Traditional barriers come from, increasing wall thickness or the depth of cover. We talked about surveillance, awareness methods. I listened, the panel discussion was very interesting, talking about people, politics, culture. There's so many things that are very important, but most of them are actually passive. They are not continuous. They are not in real time, and they are very slow to respond many times. So there are weaknesses. Every system has weaknesses. What DAS and UAV integration provides is really a new barrier, a new defense, technological defense that is real time. It's continuous monitoring 24/7. It provides a very accurate location, as I've mentioned, a couple of meters. And it's fast, and with drones, it will be an automated response. Drones can typically be, for example, at the roof of a station. It can be deployed automatically, so they will be a very good solution. So, in summary, we'll have sensing, we have detectability, classification, we have very low false alarms that are achieved by a very accurate calibration, good tuning, which comes from a lot of experience of many DAS providers, and then a very rapid response from UAVs in this case. I understand that many countries will have some limitations in terms of legislation and regulations, but I truly believe that for security reasons, for the future, I think many countries will move in this direction of allowing drones to be automatically deployed. And at the end of the day, that will be good for the operators. Will protect the environment with less pillages, and will save money at the end as well. So a fully integrated system. It's a system that will have DAS, for monitoring multiple events, both onshore and offshore. Doing peak tracking can be integrated with CCTV systems, with drones. You can send alarms to different people by text message, and is basically allowing a fast response after having a real-time understanding of the threat. So this was my presentation. Thank you very much, and I'm open to questions.
Excellent, Pedro. Thank you very much for that very thought-provoking presentation with two very interesting technologies. I'm sure you can appreciate there's lots of questions come in. Drones are quite a hot topic. I had one just before we start going through the questions that have come in, and I kind of relate it a little to an emergency response system for offshore pipelines. Often some operators can share access to a repair clamp. Is it similar in this case where operators of neighboring pipelines could share access to the drone?
Well, it's a good question. And I will probably start saying that Fotec, we are really not a drone company, right? We are distributing acoustic sensing. So we are in contact with some drone companies, and we actually have papers together with some drone companies. I'm not an expert. That's why I'm trying to say. I would imagine that the answer will be yes. So the system is very easily integrated with multiple systems, other systems. So you can integrate DAS with drones. If you can have multiple operators sharing, I would say probably yes, as long there is an agreement between operators. So typically, when you're talking about third-party interference and illegal tapping, from my experience, operators typically don't like to share those things. That's my experience, at least. Particularly illegal activities, you tend to not have much sharing of details. So I would probably say technologically, yes. In terms of regulations and even other aspects, if it's possible, that's a bit above what I can probably say.
Okay, thank you. Well, I'll try to direct the questioning towards the DAS part of your presentation, and I guess I could encourage anyone who has a question on the drones to reach out to you as a conduit.
Yeah, exactly.
So a question about the DAS was regarding the calibration you mentioned. How long does it take to do the calibration, and how often do you need to recalibrate?
Well, that's a good question. So it may take a few days or even a few weeks, depending on the length. As I've mentioned, different soil types and different fiber distance, the depth of burial will vary. You can have 1 meter, or you can have 3 meters easily in a 50-kilometer pipeline, for example. That will produce a different response. So what we typically do in Fotec, we will walk the row. So our engineers will literally walk the row, and they will simulate events along the way. So that will take several days, potentially a couple of weeks, but it really depends on the length of the infrastructure that we want to monitor. But it will always take it's not automatic. It's not something that you will buy the system and in a couple of days will be ready. I would probably say at least a week in most cases. It sounds reasonable.
Okay, thank you. I think we're actually running fairly late on time, so I'm just going to ask one more question before we let you go, Pedro. It's the classic pipeline question. What's the longest pipeline that this has been used on?
Oh, that's a very good question. Well, I don't have an answer for the longest it has been used for. I know we have monitored very long infrastructures with multiple pipelines integrated in a grid. Our longest is over 1,000 kilometers. But the good thing about this system is that you can actually add, so one system will do up to 100 kilometers, but you can add a second system and a third system and so on. So you can cover, in theory, a pipeline as long as you want, as long as you have locations at least 100 kilometers where you'll be able to deploy a system. For that, you will require typically, let's say, a valve station. You have to have power, you have to have access to the fiber optic, You have to have some sort of communication as well. So there are a few conditions that are required. Now, if you tell me I have 1,000 kilometers with 0 valve stations or any type of station in between, then we will need to talk about different solutions probably.
Perfect. Thank you very much again, Pedro.
Thank you. My pleasure.